Kia ora, Year 9. This video is about how to solve linear equations, and I'm starting with one-step equations in this video. So I'm going to go quite slowly through that. I also think that Education Perfect is really good at explaining this. If you can't find the right EP work on this, please send me an email and I'll help you find it, or I'll reassign it. Okay, so the big idea when we've got an equation to solve is the following. I'm going to start by looking at how equations get set up. So I'm going to think of a number, and because I'm in maths, I'm going to call that number x. Now, if I want to add 5 to that number, I write it as x plus 5. Okay, so if I say I'm thinking of a number and I add 5 to it, and my number equals 17, what we're doing when we solve an equation is we're working backwards to go, what was my number? And my number was x, and so that's why we always end up writing x equals blah, 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 or a equals blah, blah, blah. So when you're starting out with equations, sometimes it helps to think of this with a little bubble diagram or a big bubble diagram. So I'm starting with my number x. What do I do to it? Well, I add on 5. What do I get? I get 17. So when we're working backwards, we're trying to undo the steps that we did to get back to the start. Right, so it's a bit like playing pass the parcel when you're a kid at a birthday party. So what did I do? Well, I added 5. What's the opposite operation of adding 5? It's subtracting 5. So the number that I started with was 12. Now let's look at how we can show that using a little bit of maths. Even though you in your head know, if I said to you a number plus 5 is 17, I bet you could tell me that it was 12. So some of what we do when we do algebra is to help us when we get to harder problems. So the big idea here is that I've got x plus 5 on one side of the scales. Remember when I brought a stick into class and I looked at whether it balanced. And that is the same as 17. So what I do is I say, well, I'm going to slowly take things off the scales. And that was the lesson where we played with the Solve Me mobiles online. So it was this big idea. On the left-hand side, I'm going to undo the adding on 5 by taking away 5. But if I just took away 5 on this side, my scales would be out of balance. So I have to do this to both sides of the scales. All right, so let's look at what we're left with. Well, we've got x plus 5 minus 5 goes away to nothing. So I can think of this as x plus nothing is equal to 12. But x plus nothing is just x. So x is 12. What you have to know to be successful with solving equations are 4 operations and what we call their inverse operation. Right, so inverse is just a name for opposite, and you know these. You've known them since you were quite young, but you've never thought of them before as inverse operations. But it's good in maths to know the names of the terms we're talking about. So if I have addition, the opposite operation is subtraction, right? Addition is the plus, and the opposite is the takeaway. If I have subtraction, the opposite is addition. If I have multiplication, the opposite is division. And if I have division, the opposite or inverse is multiplication. So that's going to get me through a bunch of pattern types. So we're going to look at these on the next slide. So here are 4 little equations that we're going to start off with. Now we're going to build up to some big equations quite quickly. So just make sure that you're going slowly through these and thinking about what happened to each one. So here I've got 3x. Now we know that that means 3 times x from our earlier algebra topic. So we had a number, x, and we multiplied it by 3, and we got 15. So to undo this one, we have to work backwards and divide by 3. So we get this, 3x is equal to 15 is my first line, and then I've got 3x divided by 3 is equal to 15 divided by 3. Now, why does this work? Well, it works because the 3 divided by the 3 is just 1. And 1x gets me back to where I started, which is just x. Where's my pen gone? So x is equal to 5. So that's how we undo a multiplication equation. Now the next one has got the same numbers and the same letters, but it's different. It's x plus 3 is 15. So this is the type that we've already spotted. To undo the addition, I do the opposite. I subtract. So we have x plus 3 take away 3 is equal to 15 take away 3. I'm doing the same thing to both sides of the equation to keep it balanced. Right, so x plus 3 take away 3 leaves me with x. X is equal to 12. Right, and the next one, again, we've got the same numbers, but a different equation. We started with a number, x, and we took 3 away from it. And we ended up with 15. So to undo this one, when we go back, we have to add 3. So here's what we get. We start with x minus 3 equals 15. And we add 3 to both sides. That leaves me with x is equal to 18. Now you can probably guess the last equation. It's got the same 3 numbers, but now it's got a division sign. Now this is the one that I reckon looks worst, because when you're growing up, you don't always see the fraction line as the same thing as division, but it is, right? And so whenever we're working with algebra, we work with that fractions line, so you've kind of got to get used to it. We could write it as x divided by 3 is equal to 15. But there are some big benefits from seeing it as a fraction that we'll come to later on this year and in year 10. So the opposite of division is multiplication. So how do we solve this one? Well, let's just get rid of that ugly division sign. Well, I'm going to times both sides by 3 when my pen starts to work there. So x divided by 3 times 3 is equal to 15 times 3. Now, some of you are probably going, well, hang on, what about the 3 here and the 3 here, because they're not together? There are lots of different ways to think about this. This is a number split into 3 equal parts, and now I've got 3 of them. So I'm back to having the whole number, right? I've got x, and it's equal to 45. The other way that I can think about this one is to say that I can draw a bar, right? So I've got a number, x, and x is the whole of these, and we don't know what it is, but we know that that number divided by 3 is equal to 15. So if this part here is 15, then I'm going to multiply this by 3 to find the value of the whole thing, right? So there's 1 part, 2 parts, 3 parts. So let's look at some mixed up ones for you to try. So there are 2 to start off with. Now I've chucked in some negative numbers to make this a bit more challenging, because most of you, I think, are getting the idea of the inverse operations. So here we've got 5 times a number is 20. We want to divide both sides by 5. And that's going to leave me with x is equal to 4. We're going to do the same thing with this next one. We've got 4 times a number is equal to negative 24. So we're going to write this. 4x divided by 4 is equal to negative 24 divided by 4. So on the left-hand side, 4 divided by 4 is 1. So I've just got 1x or x. Here, negative 24 divided by 4 will give me negative 6, a negative over a positive. Here's the next one. You try this one. Pause the video and have a go at writing down your working. Okay, this time I've got a number times negative 7. So I'm going to divide both sides by negative 7. Here, negative 7 divided by negative 7 is simply 1. So again, I've got 1x or x. X is equal to negative 4, a positive divided by a negative. Next one, pause and try the equation. Negative 3x equals 15. I'm going to divide both sides by negative 3. On the left-hand side here, negative 3 divided by negative 3 is 1. So I'm left with x is equal to negative 5. Just got a few more for you to try. So here we go. All right, pause and have a go at it yourself. Right, here I've got addition. So to undo it, I have subtraction. X plus 11 minus 11 is 217 minus 11. X is equal to 206. X take away 11 is equal to 217. The opposite operation is addition, so I get this. X equals 228. Next one, x plus 5 is 57. We're going to subtract from both sides. So that gives me x equals 52. Right, now you can probably hear in the background I'm being yelled at to come and have dinner, so I'm going to finish off there. Email me and let me know if this has helped or if you still need some more practice. Thanks for watching.